Hey everyone, for today's tips and tricks to make your R stats coding life more fun, I want to tell you about a couple of functions from the naniar package, which is a great little set of functions that help with dealing with NAs and missing data by Nick Tierney. So we all know that 90% of the work in data analysis involves cleaning, getting your data to the point at which you can do some interesting visualizations or inferentials on it. And one of the things that often crops up are unexpected values in a character variable. So maybe you let your participants enter whatever they like in that variable and they enter unexpected things, or maybe there's errors or values that you would actually like to be NAs that are something else. So I'm going to show you how to use the replace with NA function from naniar to get rid of those unexpected items in a character variable. So we're going to use some data that I learned about from Elijah Butler. So this data comes from Kaggle, and Elijah posted about it as a great example of some data to practice cleaning up messiness in a data set. And so this data is cafe sales. So I'm just going to read it in using the read CSV function, and the data set is called dirty underscore cafe underscore sales. And if we have a look at this data using the glimpse function, you can see that there are items related to the item, quality, price per unit, blah, blah, blah. And the first thing I'm going to do, actually, which I usually do every time I'm reading some data in, is use clean names from the janitor package just to make those variable names more consistently formatted. So we'll run that again. And this time we can see that, let's start with our item variable. So there's coffee and cake and cookies and salad, but also this value that is unknown. And what we really want is for values like that to appear as actual missing values as NA. So I'm going to replace each instance of unknown in that column with an NA. So let's save this as a new thing so that we can compare. I'm going to take my cafe data and pipe it into replace with NA and say that I want to replace, let's give myself some more space in the console. I want to replace, and we're going to make a list. In the item variable, I want to replace every instance of unknown with NA. So if we run that, we have a new thing in our environment called Cafe1. And if I glimpse that now, we'll see that that value that used to be unknown here is now NA, right? But I know that unknown is not the only problem in this data set. So one way that I often, one method that I use to identify potential problems in character variables is by looking at using the table function to, table is really designed to count how many instances of something there is in a particular variable, but in counting them, it also tells you all of the distinct values in that variable. So it gives you more information than a function like distinct might. So in this case, I want to take our original cafe data and just look at the table function. And you can see here that we have unknown, which we have replaced, but there's also values of error in that item column. So let's have a look at how we might replace more than one value with NA in a single column using replace with NA. So it's pretty easy. We're going to, let's make a new thing called Cafe2 so that we can compare. We'll take our original cafe data, say replace with NA and use the same kind of syntax, but this time we're going to make a list of more than one value that we know we're going to replace. So we want to replace both, using the C function, both unknown and error. So if we run that and then we can maybe table our new, look at that, count how many different items there are. And if we look at that table output now, we only have cake and coffee and things that you can eat and genuine NAs. There's no more unknowns or errors. Now, if we glimpse our data again, we can see that the problems with values like unknown and error is not just in the item variable. We have problems with unknown in payment method and in location. So in all likelihood, you're going to want to replace those values within across your data set in more than one column. And you can do that with using the replace with NA all function. So in all likelihood, there's going to be more than just unknown and error. So in this case, it's useful to set up a list of values that you want to replace with NA that you can use and add to as you go through your cleaning. So let's make a new thing. We're going to say NA values, and we'll just copy this piece from up here and create a thing in our environment that lists the NA values we want to replace as a character vector. And then we can we'll make a new thing, Cafe 3, so we can compare. We'll take our cafe data, and this time we're going to pipe it into replace with NA all. And the syntax is slightly different for when you want to replace across all columns. So we're going to say condition equals, and then we're going to use the tilde.x notation to indicate that we want to do this across all of the columns. And then we want to say we want to replace with NA all things that are within, that is percent within, percent in percent, our character vector that we've set up, that is NA values. And the nice thing about setting up this way is that you could add to that, as you find new problems to replace, you could add to this NA values as you go through your cleaning process. So if we run that and then have a look, and we'll glimpse our Cafe 3 data again. Whoops, got to spell that right. Glimpse Cafe 3. You can see that now there's a lot of NAs where there were errors and unknowns before. So this replace with NA all, you can replace a particular set of values that you can adjust as you go along your cleaning process with NA in one foul swoop. Now, the other function that I really like from naniar that helps you see how much of a problem NAs are in your data set is the vismiss function. So now that we have replaced these values with NA, we can have a look to see across the data set which variables have a missing data problem in a visual representation. So if you take the vismiss function and we'll use our Cafe 3 thing that we just created, you can see over here in the viewer that we have missing values reasonably well spread across the variables. It seems like location and payment method are where most of the missing values are in this data set. So once you know where the NAs are, then you can make more informed decisions about what you're going to do with them. I hope this little deep dive into replacing unexpected values with NA was useful. Good luck.